Hi guys, it's Mrs. Jaqua. Here we are, Core 4. It's April 8th, 2014. Welcome. Today we're going to cover linear optimization and then see if there's any questions on the pretest. And since nobody's logged in, my guess is there won't be. But anyway, here we go. There's my picture. I think it's funny. All right, that's me. Okay. Webinars are Tuesdays at 2 o'clock. Get a headset. I like talking to you via headset. Unit 7. Systems of equations and matrices. The test is already out there and I've sent you messages. You can use your notes, you can use a calculator. My advice is that you get a TI-83 calculator from Miss Spillman. Or Mrs. Snyder. Actually, Mrs. Geyer is the one that has it in the central classroom, but they'll help you. Okay, find success on the test, take notes on everything you've done, hopefully you've done stuff though. Watch the weekly webinars, watch the instructional videos, do the problems, do the pretest. Meet with me if you have questions and good luck. Okay, so this is just showing you how to do finding an inverse matrix on a TI-83 calculator. So you may want to pause and practice it because it's useful information on the pretest. I'm not going to use it today when we're looking at linear optimization. Okay, so here's the idea of linear optimization. I'll give you a moment to read it. Okay, so all the problems that we're going to be working, you can see they're going to all be linear inequalities that we're dealing with. And then when we graph them and we shade the appropriate sides, we're going to come with some vertices, and these are the points that we're going to plug in to our value over there. And we're going to do two problems, so hopefully you'll have a good gist of what's going on the first set. So if I were to graph, what you do is you graph it first. Now my particular graph isn't very useful. So I'm going to come over here and show you how to graph the first line over here. But the irony is I'm not even going to use it. So that's just cool. So if I have x plus y is greater than or equal to -3, I'm going to solve for y. So y is greater than or equal to -x minus 3. And that's in slope-intercept form. So I'm going to go down 3, 1, 2, 3. And I'm going to continue to go down 1 over 1, down 1 over 1. And then I get my graph there. When I'm talking about greater than, I'm just going to shade up and above. Okay, that's a particular line that's not useful on my graph because it's going to include everything that I have. But then if I were to graph okay, and then I'm going to graph that second equation, the 6x plus 3y equals 0. But in order to graph this one, I'm going to solve it for y. And just real quick, I'm going to do that in my head. So y is less than or equal to -2x plus 8. So what this means is I go up on my graph 8, 2, 3, 4, 5, 6, 7, 8. Draw a really cool point there. And then I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. So 1, 2. I'm going to draw my line here. Okay, and then this one, it says that it's less than it, so I'm going to shade over here. Okay, and then the next part that we have is we have x is greater than 0, greater than or equal to 0. So that means that I have this line here, and I'm shading on this side. Okay, so hopefully you can kind of start to see that right now I have a border. It's right here. This is currently my border of where everything has all been shaded on top of. Let's do one more. We need blue. If I have y is greater than or equal to 0, then that's your x-axis shading above, but everything is going to congregate in this triangle. Okay, so I'm going to go ahead and put this triangle over here on this other side, just because it's easier to work with over there. And then I can point out the points. Hello. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 4. And then also this one. So this is my bounded object here, my feasibility area. Okay, and the parts that I take are the vertices, so these red dots that I'm creating. So my vertices. And this is going to be 0, 8. This is 4, 0. And this one is 0, 0. Okay, so it asked us to find the maximum and the minimum values of the objective function. Okay, so I'm going to take 0, 8. I'm going to take 0, 0. And I'm going to take 4, 0. Now I'm going to go over to this board over here and I'm going to go to the next one so you can see how I work this problem out. So if I take f x, y equals 2x plus 5y, and I plug in 0, 8, then this becomes 2 times 0 plus 5 times 8, which is 40. Okay, if I plug in 0, 0, then this becomes 2 times 0 plus 5 times 0, which is 0. And then if I go ahead and I plug in 4, 0, this becomes 2 times 4. That 4 did not show up, and I need to make my writing bigger. 4 times 0 plus 5 times, oh, that's so much better. 5 times 0, which is 8. So you can see where my max would be. My max would be this one. It's my max. This one produced my min, and it was 0. Cool. So that's it. So we're going to work another story problem so we can kind of think through it. I'm going to give you a moment to read it. Okay, so a lumber mill can produce up to 600 units of products each week. To meet the needs of its regular customers, a mill must produce at least 150 units of lumber and at least 225 units of plywood. So we have a P and we have an L. Those are what we're going to use. So what I'm going to do is I'm going to morph my x-axis into the P. Doesn't matter which one you use where, really. And this is going to be my L. Maybe we should have done alphabetical, but I didn't. So then I have F of P, comma L. And this part is going to go off of the first statement. Can produce up to 600. Oh, no, it's not. I lied. Back up. This one is coming off of $30 for each unit of lumber and then $45 for each plywood. So this is going to be 30 for, I got to back up. I'm going to write the 45 first. 45 plywood plus 30 lumber. Okay, and then my constraints are P has to be what did it say? At least 150, so greater than or equal to 225 units. It's your plywood. And then your lumber is greater than or equal to 150 units. And then we have one more constraint. So P plus L is less than or equal to 600. Okay, so we're going to just graph every line. So if I have P plus L is less than or equal to 600, I'm going to go up 600 units, which is going to be right there, by the way. And I'm going to go to the left, 600 units. And this is my P plus L. That's your P plus L. Now I'm going to do my L is 150. So if this is 600, this is going to be 150. So my L is going to be 150. And it's going to be above it. Oh, I forgot. I didn't forget, but anyway, this is going to be down here. This is going to be, I should have done this a different way, but I didn't. And then let's do our yellow one. Our yellow one is P is 225, so that's 8. 1, 2, 300. Something like here. And it's got to be greater than it, so I'm going to be shading on this side of everything. Now hopefully you can see where those three colors meet, so I'm going to go ahead and box it out. Can you see that really cool little triangle in there? This is where we're going to pick our vertices from. So this point here is 225 and 150. No, it's not. It's 225 and this point here is 225. This point is the point above, the top point is 225, and then whatever gets to 600, so that's going to be 375. And then this point on the far right is going to be whatever gets to 600 from 150, 450, and 150. Okay, so with those points, I'm going to go ahead and write them down and then we'll work them out. First of all, I'm going to write F P of L equals 45P. And you'll be able to see it in a minute. I just plus 30L. And my 3 points are going to be 225, 375. And then it's going to be 225, 150, and then it's 450 and 150. And then it's calculator time. So this goes in for my P. Oh, let's come over here. Can't even see what I'm doing. Okay, so I wrote it down because I didn't want to cover the graph, but I wrote it down. So we can see that, and if we do 45 times 225, we get 10, 12, 5 plus 375 times 30 is 10. 125. For a grand deal total of 21,375. Okay, so then we'll do similarly with this one. We're going to plug it in for P, plug this one in for L, and we get 10, 12, 5 again, plus 150, which is going to be 4,500. And we add those two suckers together, and we get 14,625. And then we got one more. Whoops, I lost the 5. And we have one more. So on this one, if we plug in for the P, 450 is 2025 0. Plus 4,500 for a grand deal total of 24,750. So let's go back and look at our list of what we want. Oh, so write an objective function. Okay, so this big slewy stuff was our objective function. That was our objective function. And sketch the graph of the region by the constants and determine by the constraints to find out how many units of each type of plywood should we produce to maximize profit. So come back to our thing over here. What number was the biggest? What's that doing? The number that was the biggest was the 450 of plywood and 150 of lumber. So let's come back over here. So we should do 450 of plywood and 150 of lumber. Did I get that right? Lumber 150. Okay, I did. Cool. Okay guys, since I didn't have anybody log in, I have no questions for the pretest. Get the test done, and that's it. Good luck.